This is the solution video for section unit 7 review, problem number 25. Let f be a continuous function that is defined for all real numbers x and that has the following properties. The integral from 1 to 3 of f of x dx is 5 halves, and the integral from 1 to 5 of f of x dx is 10. All right, so find the average value of f over the closed interval 1 to 3. All right, so remember, average value is f of z equals 1 over b minus a times the definite integral from a to b of f of x dx, right? So if we want the average value over 1 to 3, so we're going to take 1 over 3 minus 1 times the integral from 1 to 3 of f of x dx, right? So we have 1 over 3 minus 1, so 1 half, times the integral from 1 to 3 of f of x dx. Well, the integral from 1 to 3 of f of x dx is simply 5 halves, right? So this would be 5 fourths, right? All right. So that is part A. Now, B says find the value of the integral from 3 to 5 of 2f of x plus 6. So now we're going to split this up into two separate integrals. So we have the integral from 3 to 5, right? But now we put the 2 in front. So 2 times the integral from 3 to 5 of f of x dx plus the integral from 3 to 5 of 6 dx. Don't forget to make sure we integrate that. All right. Now, the first one, the integral from 3 to 5. Well, I'm given the integral from 1 to 5 and the integral from 1 to 3. So we have to remember that the integral from 1 to 3 of f of x dx plus the integral from 3 to 5 of f of x dx would equal the integral from 1 to 5 of f of x dx. So now simple algebra, we are told that the integral from 1 to 5 is 10, right? The integral from 1 to 3 is 5 halves plus the value that we want to know, the integral from 3 to 5 of f of x dx, right? So now I'm going to subtract 5 halves. So the integral from 3 to 5 of f of x dx, dx is going to be 10 minus 5 halves, right? So 10 minus 5 halves, well, 10 is 20 halves minus 5 halves, right? So let's write that as 20 halves minus 5 halves is 15 halves. So that's the value of that integral, right? So now I have 2 times the integral from 3 to 5. The integral from 3 to 5 we just figured out is 15 halves. And then I have plus the integral from 3 to 5 of 6. Now remember, the integral from 3 to 5 of 6, well, that would be a horizontal line, y equals 6, and we're evaluating from 3 to 5. And so sorry, that's supposed to be a 5. 3 to 5 is 2 units wide and 6 units tall, so that has an area of 12. And so I have 15 plus 12 is going to give me 27. So we have 5 fourths, then 27. All right, now it says given that f of x equals ax plus b, find the values of a plus b. All right, so this is one where I like to solve this graphically, right? We're told that the integral from 1 to 3 is 5 halves, right? Now, you're also told that f of x is a line, right? Ax plus b. So I'm going to draw kind of an example of a line, right? And here's 1 and here's 3. Now, the area under this curve from 1 to 3 is 5 halves, right? That's what we were told, right? So now, okay, we know that the area here, well, would be found by taking 1 half base 1 plus base 2 times the height, right? If we're going from 1 to 3, the height would be 2, right? So what is base 1? Well, base 1 is found by plugging 1 in for x. And so the base would actually just be a plus b, right? What about this one? Well, we're plugging 3 in. So that would be 3a plus b. So we get that a plus b plus 3a plus b, right, is going to be base 1 plus base 2. And so this area is going to equal 5 halves, right? And so what can we say? We can say, let me move this up a little. All right, we can say that a plus 3a, so 4a plus 2b is 5 halves, right? So that's one equation. Now, this has two unknowns, so now we're going to need another equation. Okay. Now, just a minute ago, we figured out that the integral from 3 to 5 was 15 halves, or we could use what we were given. The integral from 1 to 5 is 10, right? So now, in the same way, we can say 1 half base 1 plus base 2 times the height. Well, now if I'm going from 1 to 5, that's a width of 4, right? Base 1 is going to be a plus b. Base 2 over here is going to be 5a plus b, right? And so 1/2 of 4 is 2. So I'm going to get that 2 times a plus 5a. So that'd be 6a plus 2b is going to be an area of 10, right? So now I can divide by 2 and I can get that 6a plus 2b is equal to 5. So now I have two equations and two unknowns. So 4a plus 2b equals 5 halves and 6a plus 2b equals 5. So now I'm going to subtract, right? So I get 4a minus 6a is negative 2a. 2b minus 2b is 0. 5 halves minus 5, so that'd be like minus 10 halves, so that'd be negative 5 halves. So now I'm going to divide, and I get that a is equal to 5 fourths. All right, and if a is 5 fourths, then let's find b. So let's take that first equation, 4 times 5 fourths plus 2b equals 5 halves. All right, so 4 times 5 fourths is just 5, so I'm going to subtract 5. So 2b is 5 halves minus 5, or minus 10 halves. So that'd be negative 5 halves. And so I'm going to divide by 2. So I get negative 5 fourths. So A is positive 5 fourths, B is negative 5 fourths. All right. So that is problem number 25.